Okay, today we are going to go over evaluating algebraic expressions. Evaluating algebraic expressions. And by algebraic expressions, I basically mean polynomials. So evaluating algebraic expressions, what do we mean by evaluating algebraic expressions or evaluating polynomials? Well, let's say we have a polynomial like this, x squared minus y plus 2 times y squared plus 1. Let's say you have a polynomial like this, and we want to find out what does this polynomial equal when x equals 2 and y equals -1. Okay, so basically what we're doing is we're putting in these values. Let me use different colors here. So x is 2, so I'm putting 2 where x's are. There's only one place where there's an x. And I'm putting a -1 where y is. Okay, so let's try plugging these in. So the new expression that we'll get is we plugged in 2 for x, so that's going to be 2 squared minus y is -1, so there's a -1 where y is, plus 2 times -1 squared plus 1. Okay, and we just need to simplify using the order of operations. Using the order of operations, we just need to simplify this expression. So the order of operations, just a reminder, it's PEMDAS. And the first thing we need to look at is the parentheses. Can we simplify anything inside the parentheses? And inside the parentheses here, we have some expressions that we can simplify. Inside here, we have some expressions we can simplify. So here, what do we do first? We have 2 squared minus a -1. And if you look at the order of operations, we need to do the exponents first. So let's do the 2 squared first. 2 squared is equal to 4. And minus a -1 is the same as plus a +1. We can change both of these signs to a plus. So we have 4 plus 1 here, plus 2 times, we have -1 squared, which is just 1, plus 1. Okay, and then we have 4 plus 1, which is 5 on this side, plus 2 times 1 plus 1 is 2. Now, according to the order of operations, we need to do the multiplication before the addition. So we need to do this part first. So we'll get 5 plus 4, and that would equal 9. So this would be our answer. Now in this case, we got a nice whole number as the answer. But in some cases, we might end up with variables as answers. So let's look at an example like that. So let's say I have a polynomial 3x squared plus 5xy minus 3. And I want to evaluate this polynomial when y equals -2x plus 1. So notice y doesn't equal a number, but it has the term x in it. So what we do is we basically do the same thing. We just put in this value for the places where there's y. So there's y right here. So that's the only place where we put that in. So the other ones we can just leave it as is. So 3x squared plus 5x, and where there's supposed to be the y, we just plug this in. -2x plus 1 minus 3. And again, using the order of operations, which one do we need to do first? These are kind of grouped together. We have parentheses. There's nothing to do inside the parentheses. So we skip that part. Exponents, the exponential expression is already simplified. Multiplication or division. So we have a multiplication here and addition and subtraction here. So we need to do multiplication first before we do addition and subtraction. So doing this first, we get, remember we need to distribute to each terms. So 5x times negative 2x is going to be negative 10x. 5x times 1 is going to be 5x. And then we can write the terms that we haven't touched on each side like this. Now we just have addition and subtraction. So we just work from left to right. But there's only one thing to do because we only have two terms that are like terms. So we combine these two. Negative 10x plus 5x is going to be negative 5x. And on this side, we have negative 3x squared. And on this side, we have a negative 3. And because we can't simplify this expression any further, this will be our answer. So in this case, we substituted something that had a variable in for y. So this, we put everything in terms of x. We knew that y equaled this. This was given, so we plugged that in for where y is, and we just simplify the expression using order of operations, and we get the answer.